So I thought I'd go through the Vsper chart and talk about what molecules, what shapes are generally polar or nonpolar. Let's just get into the first column. That actually has the potential of being nonpolar or polar. It all depends on the symmetry. So if the central atom is surrounded by the same atoms, even if there's an electronegativity difference between the two, even if the bonds are polar, the whole molecule can be nonpolar because the central atom is getting pulled equally the same amount, and there's that symmetry if it's surrounded by all of the same atoms, or surrounded, yeah, if it's surrounded by the same atoms. But the minute you change one of the atoms, you create this dipole, you create this new place where they're not sharing this electrons the same amount in that one bond, and now the whole molecule has polarity. So that's the thing about that. But the second column, when there's one lone pair, all of those will always be polar because the lone pair will always create this like dipole happening towards it for the most part. But yeah, that just messes up the symmetry, and those will always be polar. Same with two lone pairs, the same reason. It's just there's always the symmetry where there's going to be a negative and a positive parts of the molecule, of the bonds. And then, but the only exception to that is square planar. As you can see that symmetry of the two lone pairs canceling each other out on top of each other, and there's the four bonds to it. That actually can be nonpolar if the four atoms are the same because of that two-way symmetry. That's the thing you want to look for. It's like two-way, like a bunch of symmetry that it will cancel out the dipoles. Same, and then three lone pairs, you can see that the three lone pairs cancel each other out, and it's a nonpolar in nature. Oh, sorry, that was really long.